Good evening. My name is Lynn Denon, and I am Director for Academic Programs with Stanford Biodesign. I am standing in tonight for our director, Josh Mackauer, who is unfortunately under the weather. But on behalf of Josh and the entire Stanford Biodesign team, it is my pleasure to welcome you here this evening for the first Innovators Workbench event of 2025. Woo! Thank you. All right, so we started this event series in 2003. And every year we've welcomed luminaries from the health tech industry to campus to share stories of their lessons, insights, from their innovation journeys. And the impressive lineup of speakers has included pioneering inventors, startup founders, incubator teams, corporate leaders, investors, and other movers and shakers from our field. This year, the guest list is as inspiring as ever, but the special thing is that it's really all the speakers are from our immediate family. So for the first time ever, we are featuring alums of our programs, people who have joined our team and will be focusing on their accomplishments since they've had their Stanford Biodesign experience. And we are delighted that the first of these events begins with Dr. Uday Kumar. He's an early alum of the Stanford Biodesign Innovation Fellowship. I did not say an older alum. All right.
I'm an OG.
An OG, even better, yeah. Who's gone on to have an incredible career as an innovator and executive, as well as a mentor to hundreds of aspiring health technology innovators. So Uday founded iRhythm Technologies based on a project he initiated with his team out during his fellowship training. And the Zeopatch.
Right there.
Yeah, right there. The Zeopatch technology for arrhythmia monitoring has become one of the most recognizable biodesign success stories. Just take a look at the second edition, the cover of the textbook. Now Uday is leading his second major venture in the cardiology space as president and CEO of Element Science, which you'll hear more about tonight. So I first met Uday when he was fresh out of his fellowship training, and I've had a chance to keep tabs on him ever since. Not only has he had a lasting impact on the health technology innovation landscape, but he's also had a lasting impact on Stanford Biodesign itself. He was instrumental in starting and managing our first global partnership, the Stanford India Biodesign Fellowship. And he became the Global Fellowship Director for India and Singapore. He joined the faculty team for the Innovation Fellowship. He plays a key role on our textbook project, co-leads our executive education program, and is a senior advisor to the organization. So thanks, Uday. Interviewing Uday today is another of our esteemed Innovation Fellowship alums, Kate Rosenbluth. Coincidentally, I also met Kate fresh out of her time in the fellowship, and I've been equally as impressed with what she's accomplished. Kate is the president and founder of Cala Health, a company she created based on a project initiated during her training. She also teaches biodesign in the Master's in Clinical Informatics Management program here at Stanford, as well as contributing to our executive education program. So Kate and Uday both have built device-enabled service platforms that have had a profound effect on how patient care is delivered in their respective areas. So this is going to be fun and incredibly interesting. Before I hand things over to Kate to start off, I'd like to thank our sponsors, Wilson Sonsini, and I want to give a major shout out to all the Stanford Biodesign team members who have prepared for and are executing this event so flawlessly, especially our event coordinator, Deja Hill, who is probably hard at work. Please turn off your cell phones for our talk here. And without further ado, let's get this conversation started. Kate and Uday, welcome to you both, and take it away.
Perfect. Well, many thanks, Lynn, and welcome everyone to what's sure to be an engaging conversation. It's a great joy to sit down with you today, Uday. You are an exceptional innovator. You've had a phenomenal career already, and I know there's a lot more coming, so we'll probably be having to do this again someday. I met Uday as a Biodesign Fellow, and as a fellow innovator in the space of home use medical devices. I just say you really can't understate the impact that iRhythm Zeopatch had in really elevating the bar on patient-centered design, innovation, looking at what's really possible when you reimagine that intersection between technology, patient care, and the clinical workflows. Of course, now today you've moved on from really recreating the space of cardiac monitoring in the home space and then bringing that into the home use therapeutic area in the area of wearable cardiac defibrillation. So what's so great about the Innovators Workbench series is that we also get the opportunity to go into all of the stories behind these successes, put these in a moment of time. It's a transition time right now. President Trump was just sworn in on Monday. Also, just to note in time, we're right now dealing with the wildfires that are raging in Southern California. I know I speak to everyone here. Just saying that we wish everyone impacted by that is safe and that we can all come together as a community to help with the recovery as well. So we have a lot to cover in your journey as a physician, as an entrepreneur, at Biodesign, both here domestically as well as globally. So let's jump in. And let's first go back to the beginning and start with, where did you grow up?
Yeah.
And how did you get interested in medicine?
Great. Well, it's great to be here. It's kind of crazy to think, like I was pointing out earlier, like see where my kids are. That's where I sat almost 19 years, a little under 20 years ago when I was a fellow. To be here is kind of really remarkable. And again, I see so many familiar faces, so it's really nice and thank all of you for coming. So my journey, actually, you brought up the administration change, so I'll just go back a little bit before. I've reflected a little bit about why I became an entrepreneur, and I have to think about it from the standpoint of my parents. So my parents came here as physicians in the early 70s. In 1965, Johnson signed the Immigration and Nationality Act to kind of reduce quotas for different groups to come to this country, and the U.S. needed physicians and engineers, well-trained, English-speaking. So they came to a country they knew nothing about, and I think about, even though I'm an entrepreneur, they were pretty pioneering, and I never really thought about it that way, but all the talk about immigration and what immigrants go through, it really resonated that there must have been something in that DNA about coming and trying things, being told no a lot. So they settled in Rhode Island, where I grew up, where they did their training. I always ask them, did you not know about California? They said, well, we settled there because we wanted to be near the good schools that we knew of. So we'll get to that in a minute. But so yeah, I was an only child, growing up with two parents who were private practice physicians. Like many kids back then, very good at math and science. I really enjoyed a lot of those subjects. And so as I went to school, I went to Harvard for undergrad, being near the good schools, I guess. So I studied molecular biology and biochemistry, and I thought I would go on to do a PhD, but I realized at that time the translation for some of those things takes time. And so I got interested when I went to med school, also at Harvard, in the administration and the business of medicine. In the mid-90s, that was starting to become more recognized as an industry. Was still considered the evil empire by physicians back in the 80s and 90s. But I was seeing that there were some opportunities now of having physicians think about, how do they play a role in thinking about what they take for granted and use every day. So I went through med school, but I realized I was just a guy who had a medical education. I didn't really know much about entrepreneurship, or I didn't know much about business. And so I did the first thing. And so hopefully, as you leave today, there'll be a whole bunch of lessons and takeaways, that, especially for the young entrepreneurs, that you'll take away. So the first thing is, if something seems very green on the other side, try it. So I actually took a year off after med school to get a company off the ground and doing 3D printing. It was from some friends of my wife's who were at MIT at the time, and there was an idea of how do we use 3D printing potentially in medicine. And so we started this idea where we would make physical models. And again, 3D printing back then was really in the purview of car companies and other companies to make parts to test things on, not at all in medicine. And so we basically were able to take CAT scan and MRI data and create complex anatomy, skulls, and other things for complex procedures, with the idea that physicians could practice and make ostomies and so save time in the OR. So it was a really, really interesting experience, but it also taught me that I was not an expert at anything yet, but I also had some value in terms of understanding how the intersection of this service, that was a service, it wasn't really a technology, we were applying a technology, that'll be a theme that'll come out. But then I realized I needed to go back and become an expert at something. So that's when I went back to residency. So I can keep going in terms of that a little bit. So I did my residency at Columbia in New York City. I didn't realize this, and though I always wanted to live in New York, but training up in Washington Heights was really informative in terms of the patients I had to take care of, where they came from. I had a lot. We used to see patients coming straight from the Dominican Republic, straight to the emergency room. People from Puerto Rico, Black Americans living in and around Harlem. So this was my patient population, a population I hadn't really seen much of at Harvard or growing up in Rhode Island. But it was really amazing to kind of understand, and again, we'll get back to some of the themes we'll talk about later, about how patients, how many assumptions are made about patients and where they're from. But these were great patients. They always wanted to do the right thing. I got to speak Spanish to most of them much of the time. And so that was a really formative experience, which also helped me when I thought about coming where I wanted to do cardiology. And I also got interested in technology. That's why I became an electrophysiologist. That's a cardiologist who does all the abnormal heart rhythms. So long and short, as I came to UCSF, that's when I first learned about the biodesign program, Paul Yacht. So when I was applying, Paul was just starting the program around, it sounds weird to say this, turn of the century, but yes, the turn of the century. So, it's true though, turn of the millennium really. So at that point, he was saying, we're starting this program, you've been an entrepreneur, maybe you think about it downstream. So I said, okay, but I was fortunate to get a cardiology and EP spot up the way, and so I started there, really focusing on how do I become a good physician in this field, but always with the back of my mind saying, well, I'm now in the Bay Area, a hotbed of healthcare innovation, and one of the other lessons I'd say is, increase your probability if you want to do something like this. So I like to say, and some of you might have heard this before, maybe 1 in 1,000 people can start a company in the U.S., maybe 1 in 100 in the Bay Area, maybe 5 in 100 here. So you've increased your odds logarithmically, even though it's still hard. So one of the things that I learned from that is not just doing experiments to figure out, do I like being an entrepreneur from my entrepreneurial experience at a 3D printing company, but now putting myself in a place where there's a network of people, there's a milieu, there's a culture that increases the odds. It's still super hard, but you increase the odds of these random interactions allowing something to happen. So after I finished electrophysics, I ended up as a biodesign fellow to come back to the network, and I was fortunate at that time, Paul and Josh was my fellowship director. They said electrophysiology is going to be our focus area, which is unusual. Most of the time, physicians are not in the same area of their specialty, but it was a perfect opportunity for me to bring kind of my knowledge of the domain and have a great team with different experiences come together.
Perfect. Well, I love, we're going to come back to a lot of the themes that you touched in there, including, I love seeing sort of how your focus on treating more socioeconomically, racially diverse populations really informed where you went in iRhythm and further into Element.
And just one other thing I'll say, sorry to
Yeah,
interrupt.
go ahead.
Just that my time at the General, up at UCSF was very formative too. I had my clinic at the VA, and we used to take care of patients all the way from the Oregon border who would come. And I think that informed a lot of, as we'll talk about a little bit, about iRhythm and mailing patches in and moving patches to where the patients are. And then also taking care of patients at the General. A lot of different people experiencing homelessness, people who had substance abuse, addictions, other things. But by and large, the vast majority are good patients. Some people experience homelessness are some of the best patients iRhythm has had. So I do think that thematic experience of being in places where you have a human interaction with a patient and you realize that pretty much are like every other patient really goes a long way to thinking about some of the themes that will come through in some of the companies I've been involved in.
I think that's such a great takeaway. True to the spirit of biodesign, can you walk us through what was the unmet need that you were tackling, and then how did iRhythm and the Zeo patch address that unmet need?
So I see John White here, one of a friend and our teammate from, you're over here now. You were over there before, you moved. So like we sat over there and we were, like I said, tasked with electrophysiology, and we had a lot of great needs. This was at the time in the mid 2000s where a lot of electrophysiology was booming in terms of AFib, atrial fibrillation technologies, defibrillator studies, et cetera. And so, this need for a better way to diagnose arrhythmias actually came from also my time at the General, where I had to read Holter reports, and it was terrible. It was just so bad. It was like, this is ridiculous. And so we had this need because many of us saw this, but it was really not very, and again, for many of you know the biodesign process, and many of the fellows here, you come up with hundreds and hundreds of needs. This wasn't even up there. It slowly made its way by following the process up from the 11th mixed need out of blue sky and incremental, all these different types of needs, and eventually got to our top 10. And it was an interesting one because it was something that, you know, was a diagnostic. It was a, you know, people knew that people need to be monitored. So at the end of the fellowship, we all had to do different things. And even though we've talked about it in the past, like I was thinking about, well, what do I want to do next? And so after I finished the program, I actually took some time off to do some other needs finding. That's actually where the need for Element came, which we'll come back to. So I'll hit on that. So before thinking about what to do next, I did some needs finding. There was an unmet need about how do you treat people who could die suddenly. Because there's some papers about that the 30 days after a heart attack is a very high risk period. And as an electrophysiologist, we didn't do really anything for that. And I'm shocked that we, no pun intended, that we didn't that we didn't actually come up with this need when we were our team. So I filed a patent for a adhered defibrillator, which this was before iPhone 1. I know, for those of you like, what? Like, yeah, so miniaturization technology was not at the place it needed to be. So I was like, okay, I'll just pursue this with someone I met here, Jim Shea, who is now retired, but he's been our IP lawyer for a long time, but he had been in-house counsel at an AED company way back in the day. So he knew the field very well. So I said, we'll just pursue this and then I'll go think back what to do. And that's where I kind of resurrected the idea that, you know, that the idea for iRhythm. And that was, again, the need was a better way to monitor non-hospitalized patients who are suspected of having arrhythmias. That's really basically was the focus. And what we had created here, our original patent, was the idea of a patch-based technology. And you know, many of the classes I give here, if you see the original whiteboard drawings, it looks very, I mean, there's 3 examples in one of the cases over there. It looks very, very similar. So from the product perspective, I think we were right on. I think one thing that happened afterwards, that really has been the DNA of the company beyond the patch, was the software and the algorithm. That has really been which is now a deep neural network, many layers, developed here with Andrew Ng in the computer science division. But so the need was partially solved from what we did here. But once I started the company and licensed the technology and raised the capital in January 2007. It became very evident early on that using a product to monitor a patient for 14 days, recording every heartbeat, generates a lot of data. And the typical way of analyzing that data was for humans to use PC-based software to go through and kind of come up with where there are arrhythmias or not. That's not for a typical Holter monitor, which is 24 hours. That would take 30 to 45 minutes for a human to do. Not possible for 14 days. They would just, and again, the reimbursement at that point in time was $100, $150 for that test. So not at all possible. So what were we going to do? And so that's when we thought, and this is another lesson that I think I'll impart, what are other industries doing? And so at that time, cloud computing was becoming something important. Not in healthcare yet, not even close. But we were looking around, and I give credit to a guy named Mark Day, who was our early head of systems development back then, of kind of introducing the idea, hey, how are we going to scale this? How are we going to run lots of computing processing? And so we were very early adopters of cloud computing. Amazon's S3, we were on that probably in 07, 08 probably, way back when, to start to think about using an algorithm. And the algorithm was clinical rules that I had to come up with. How do you detect all of these different types of arrhythmias, from slow ones to fast ones? That started the basis of what eventually became a machine learning algorithm, which eventually became a deep neural network. So anyways, a lot of different things, but it started here with a need that we got partially right. So again, oftentimes needs are solved in different ways. I like to think of iRhythm as a healthcare IT company enabled by a novel device supported by a service. So the company is where I learned how to build the other 2 legs of the stool. We had one leg identified here, the physical product. And I think over time, more and more solutions, so many, are intersections of these technologies as software has become a larger and larger part of the toolbox we use to solve problems. And you might have to solve many problems. The other thing I'll mention is sometimes you don't have to do everything you can. So what do I mean by that? So at that time, cell phones smartphones were getting to be more in use, but not yet very broadly used. And so people were saying, well, if you're going to develop this technology, why don't you transmit all the data? But that was very costly, and many patients, very much like many patients I had at the General, or my vet patients, or people I had at Columbia up in Washington Heights, they didn't have access. They couldn't pay for smartphones. But they knew something that we all know, the mailbox. And the Netflix model back then of mailing DVDs back was very ubiquitous. It worked. And so one of the first things, even though we could have made the technology, made the ability of getting data off of that patch into a cell phone or a smartphone to then transmit possible, it would have been prohibitively expensive and limited access. Access to many of the patients who actually need a diagnosis when they're first coming and presenting with a symptom. So we made the decision to not to do that, to not ride all the rides and use all the technologies as we typically do in American healthcare, and say, you're going to mail it back. And that's been the predominant approach, and we have at 10 million patients now. The vast majority do that. The US Postal Service, for how maligned it is, still works. And most importantly, whether you speak English, whether you have a home or not, you know where a mailbox is. And we give them the box that they get it in, turns into that. So very kind of not frugal innovation, but very thoughtful innovation, because if I was a patient and having taken care of these patients who want to do the right thing, how do we lower the barrier to meet them where they are versus forcing them to do what we think is right for other patients? And so that was an example of very high technology, cloud computing, AI on the algorithm, and very low technology, snail mail, to solve another piece of the problem. So you don't always have to solve a need that has multiple parts with the best and most expensive and the shiniest. Sometimes very simple things work.
So if we keep rolling forward that very thoughtful innovation, I understand that the VA and integrated systems like Kaiser were some of the earliest to actually adopters of Zio. And I'm curious for everyone, both here in the room and online, when you step back as an innovator and you think about your challenges both in regulation and reimbursement, how do you think about the relative risks and challenges for introducing a new product like this?
Yeah, so like I said, cardiac rhythm monitoring was not new. We had lots of different devices, historical, that had been around for decades. But when you're developing something new, the first question we got was like, why do we need another monitor? We have monitors. But again, these latent needs are oftentimes very interesting ones because they're right in front of you. So we spent a lot of time mapping the healthcare system. So much of iRhythm's success has been business model innovation. So if you actually, in some of the classes where we go over this story, we kind of mapped out how when someone would present, so if any of you have gone to your doctor saying, oh, I felt my heart, I had palpitations, I feel fine now. So what would your doctor typically say? Like, well, let's just see what happens again. So they're telling you, you had something, but let's have it recur. Who says that? We do. And that's how American healthcare is. But that means that you come back and you're told the same thing. Or, like my mom would tell me as an internist, when they come to see her, their back pain, their back hurts, their neck hurts, palpitations gets put low on the list. And as an internal medicine specialist or a primary care doc, you don't have the tools at your disposal. So there was a whole thing that we could map out where we waste so much money on telling patients keep using the system until they get to the point where they're high enough acuity, and then we give them technologies that only record for a day or two at a time when their symptoms may not happen for weeks at a time. So it was a lot of mismatch. And so when we talked to, Kaiser was an early investor, Kaiser Ventures actually, because I'll give you an example. So when you go to see your primary care doctor and your blood pressure's high, they manage it to the point, but then they say, I can't manage it, I'm going to send you to a specialist cardiologist because it's out of control. But you go to them with a diagnosis. When you have a potential arrhythmia because you are lightheaded or you are feeling short of breath, oftentimes you'll be sent to the specialist to have the specialist work up whether you need to see the specialist. Well, you just think about that. You have all these very expensively trained physicians in demand who really could be spending more time doing valuable procedures, now having patients in their clinic who may not even need to be there. And so and Kaiser really understood that, because as someone who's both the payer and provider, having beneficiaries not being able to get into cardiology because they don't have enough means you have to hire more cardiologists. But you're also having slots taken up by the cardiologist for patients who may not ever need to see them. And so if you can move monitoring to the first entry point, that was really why the Zeo patch was a single-use device that can be put in a primary care office, in an ER, was developed. So the minute a patient starts complaining, you can start the monitoring. And then you can move the information. And this is where my VA experience. So I felt terrible. I mean, we do a disservice to our veterans to make them come all the way to get a Holter monitor and take the bus. They love it. They're fine with it, but it's just not right. And so the idea was, how can we start the monitoring where they live, wherever they are? And then we, as the main clinic, if we read their report and find an abnormality, then we can tell them to come, right? That makes more sense. It's also, they deserve it. So, I mean, as what they've done for the country. So I think these type of experiences highlight that there's so many opportunities to do better with just understanding the movement of people, the movement of money. And so Kaiser and the VA, the VA again, because they totally understood, because when I explain things like I just explained to you, they're like, yeah, that's ridiculous. We should use your product. We should try your product. And so that's how it started.
Well, I see a lot of nodding heads out in the audience as you're walking through this. Let's move forward to today and tell some of the story of Element Science. So you're now founder and CEO at Element. You noted that some of the early concept there came from earlier on as well. Element has a very exciting product in development, and I think is also taking a very exciting approach to kind of changing the complexion of our industry as well. What did you set out to accomplish at Element?
So a little bit on that transition. So 2007 was, like I said, when iRhythm was started. I was there about five plus years. By the time we launched the Zeo in 2009 or 10, and a lot of it for the next 5-6 years until our IPO in 2016 was getting reimbursement. Really having these moving goalposts among commercial payers saying you need to do this many papers, this many papers, this many papers, show this value to get coverage. And so at that point in time, this wasn't a situation where I'd been traveling around, got to know a lot of the physicians. They were like, we love the product, but come back when 80% of our patients can get covered. Because that's typically, they don't want to have so again, if you're a patient, I'm sure you've received what's called an EOB, an explanation of benefits. It's a terrible term because it's not a benefit. You have to look at how much you owe. So the idea of these EOBs is the fact that doctors don't want their patients to get one and then come complain to them, why'd you prescribe that? Now I owe so much. So they really wanted patients, around 4 out of their 5 of their patients, to basically be covered so that they knew when they prescribed it, they would be not having to get these irate patients back. So at that point in time, in 2011, the patent for Element that I filed and been pursuing my own got issued pretty broadly. I mean, got issued as a pretty broad patent. And so it was a question of like, okay, well, what's the market like? And so there was one competitor product at the time, the Zoll Life Vest. This was a product that was a vest that, again, at the turn of the century was invented, was quite an advancement to basically being able to wear a defibrillator. It was kind of carrying around a couple pound pack on your belt and having this kind of very tight vest around you. And it was primarily used for patients who had IC implantable defibrillators that might have been infected or needed to be taken out for some reason, and they had to be protected for some short period of time. However, as I was saying, this was the heyday of electrophysiology. A lot of large trials, and among other things in terms of what you could and couldn't do with implantables, suggested that there was a role for these wearable technologies in temporary periods. So after a heart attack, in the first 40 to 90 days, you have a high risk of dying suddenly. And then either after that period, your risk goes down, or you need to get to an implantable. Implantables were shown not to actually have benefit, not in preventing death, but they had so many, these patients are so sick, they have other causes of death. The mortality benefit of implanting in a defibrillator and all the cost that comes with it basically negated. So CMS said there's a window where you cannot use an implantable because it could cause the same amount of death that it saves. So doctors, electrophysiologists, well, what do we use? let's start using this wearable. So that was the market was starting to take off. Technology was starting to take off. I learned a lot from iRhythm in terms of wearables, et cetera. And then, I took a little diversion to Third Rock Ventures where I was an entrepreneur in residence. I had known them for a while. They basically develop companies in-house, build companies primarily in biotech. But long and short of it is when I was there, they said, do you have any other ideas? Well, I have this patent that just issued, and it seems the market for the competitor product is growing. It seems there's a clinical need that's now clearly identified. And so one thing led to another, and Google Ventures and Third Rock Ventures. Google Ventures, I'd known, they had looked at iRhythm in the early days before they'd really started healthcare investing. Did our Series A back 10 years ago now, 2014. And that was basically with a sketch of what this defibrillator would look like, that it was now a patent. And true to form, being Silicon Valley, a napkin sketch that's now basically a product that's about to be commercialized. So that's where it started. But in terms of starting the company, I think as we went, there were a couple things. I've been very fortunate to be, iRhythm's done very well, household name now. And so the question was, what do I want to do with a new company other than build a product? I think a couple things. If you haven't got the sense, socioeconomic and kind of impacting a broad range of people, starting from all the experience I had, was really something I wanted to make sure this company did. And as iRhythm was a very diverse company in terms of our employee base, just happenstance, so just as a side note, just also thinking about solving a need, we started the company in San Francisco. So in San Francisco in the mid-2000s of iRhythm, in the Soma district, which used to be where live-work lofts were supposed to have happened in the dot-com era, and it never did. It was kind of half full back in the mid-2000s. There were companies like Sega and a lot of design companies, interior design, interior architecture, all that kind of stuff. But there were a lot of really smart people in San Francisco who were taking buses down here. And we had the idea that, and I also lived in San Francisco, so it was a little selfish on my part, but we had the idea that, if we could start a company here that's kind of doing these things, and could we attract really good talent who didn't want to take a bus? This was in 2007. So that was prescient. I mean, it was lucky, but we were smart. For whatever reason, it all worked out. iRhythm's headquarters is still there, even though there's a lot of remote employees now. But then 2010 happened, and the whole epicenter of development from the semiconductor industry down here to the kind of information technology industry and now AI is up there. And so 2010 Soma, before COVID, was crazy. San Francisco was like crazy. And so, rents, everything. And so that was one of the reasons in terms of kind of why we also started Element up in the city. But one of the things was we still wanted to be true to, back to my original point, how do we build a very diverse workforce? Because ultimately our patients, we're sticking products onto, I look at this room, everybody's skin's different, everybody's social norms are different, cultural history, how you moisturize, tons of different things. And you don't know those things if you don't have people in your company who live that. And so one of the first, and then if you, as Lynn mentioned, some of the things we did here at Stanford, we kind of really also looked at the industry, and we realized that the industry, medtech as a whole, is still much more like engineering than medicine. Medicine, go to med school across the way, 50% women, very diverse. Engineering, not so much. It's still primarily white male oriented, but it's changing because just engineering in general has been. And so, we wanted to figure out, well, how do we change this? Because if the patients we serve represent so many different communities and the products we develop actually really matters, how do we think about that? So one of the goals of the company is, how do we change the complexion of the industry to make a better product? Second, just like we did at iRhythm, how do we think about new technologies and toolbox? So, like I said, we learned a lot at iRhythm. I learned a lot at iRhythm, but at that time, machine learning, et cetera, was now something we started with. So instead of graduating from clinical decision rules to machine learning to AI, our algorithm started right away, the one that is on board our defibrillator, as a machine learned algorithm from the beginning. So a little note on that, since this is the age of AI. Typically, cardiac algorithms are how a cardiologist looks at an EKG. You see a different a P wave, a QRS complex, the typical things that you see on TV. they all represent different parts of the heart contraction and relaxation. But that's how we as physicians look at it. But if you think about it, an EKG is a squiggly line. It's just a line, basically points sampled over time at different kind of voltages. That's all it is. And so there's a lot more information than what we as humans look at. And so if you think about that, what we want to do as a defibrillator is determine if an EKG is shockable or not shockable. It's really a binary classifier because we want to know whether we need to shock you or not. And so when you look at a squiggly line of someone's about to die, when you see all this like stuff that you see on TV or a flat line, there's a lot of information there. And so we kind of, another close friend of mine, another Biodesign alum, Pedram, he was working up in Medtronic and neuromodulation. So I said, hey, you've been working on things related to algorithms in EEG, but we're doing EKG. Maybe you should we should work together. So he became our first head of algorithm engineering. And so we merged the best of cardiac and neuro to really think about what are all the features of a squiggly line that distinguish something that's shockable from not shockable. And so you come up with dozens and dozens of features, Fourier transforms, power domain, all sorts of things that we wouldn't do as physicians because we're not as smart as computers in some ways like this, pattern recognition. And then you really figure out what are the best set of features and what set of decisions to identify. And so that's how we started the algorithm. So we really looked at how to bring in that technology right away. But again, it's not as complex when people talk about machine learning. It's just how do you think about it to solve your problem? So complexion, new technology. And I think the other thing was really making sure that this was a time, 2014, that I couldn't have imagined where we were in 2016 and 2024. But even thinking about back then where we would go to launch, et cetera. So fast forward a little bit, we launched our trial. Our first patient was in Little Rock, Arkansas. And we ran our trial all in the Deep South, the Midwest, up in the Northeast. There were no patients west of the Mississippi. Why? Need. There are so many populations in these areas where there's patients who don't get access to these technologies. Our trial is a cardiovascular trial, so we had to run a large trial for our IDE. We had about a 300-patient trial. For a cardiovascular trial, we were almost a third women and a quarter black patients, which is very unusual, very, very unusual. But it was intentional in the sense that, and we had 8 saves, and we were supposed to have 1. It just highlighted how much unmet need and these patients, how sick they are. And again, it goes back to this idea that even in the political landscape, there's demagoguing, et cetera. It's good business. Like, we are saving healthcare dollars by helping these patients. I love the fact that for how much San Francisco is maligned. I love the fact that we're here and we're helping patients in Kentucky, in Arkansas, Mississippi. It's great. They're fellow Americans. We want them to do well. So it was really also trying to think about how do we change the narrative to really bridge across socioeconomic lines, because everyone who's going to die suddenly cares about their loved one. It doesn't matter what you look like, where you're from. And sometimes people at risk in the different communities have more in common than not. So a lot of different thematic things other than just building a technology.
Something else that really stood out to me in that study, which I happen to have here, this was published in just 2024 in the Journal of the American College of Cardiology. I just say it is a very impressive study in its clinical outcomes. One of the other things that really impressed me in this study was noting patients use the technology for 23 hours a day. And that's not easy to do. And I'm curious sort of how you think about patient-centered innovation and design and how you weave that throughout your process.
Yeah, so that was the number one thing that I think that the existing technologies that exist today, they work. They're good technologies, but they're really difficult for patients. These vests, you have to wear them really tight against your body, and everyone knows you have them because you're carrying around this couple-pound pack, which is the battery pack and the capacitors. And so a couple things that patients, they don't like other people to know that they're sick. And the first thing you see, and if you've ever been around someone who's sick or has some sort of device, even if you're their friend, you forget about the fact that they're your friend. You just like now, they're this other entity. And patients don't want that. They want to be treated. You don't help people get better by thinking of them as sick. Being sick is hard enough. Like, why does everyone else have to think I'm sick? So discreteness was really important. Second was we weren't trying to reinvent the defibrillator. We were really trying to reinvent the experience. So Google Ventures, which rarely does medical devices, said, when we started the company, Martin, our head of design from way back when, and I were talking about the fact that how do we take something that, I don't know where the AED is in this place, but every AED, every ICD is basically something in a hard shell. You can't stick a hard shell to a human body of all different shapes and sizes and expect it to work. So you have to throw out the dogma of putting everything high voltage in one compartment and break it up. And so the first thing was, how do we create something that humans can wear through all different body types, body shapes, and activities? So you have to think about building a defibrillator differently. So it ultimately then comes back to, how do you develop an experience and build a defibrillator into the experience? Not build a defibrillator and hope patients can use that experience. That's what typically happens with many home-based patient-centered products, because you're actually not thinking about the patient. You're thinking about what they could do as opposed to what they really are like. And so that's why the product, it has these 4 pieces. They're very flexible. They have a lot of degrees of freedom. That was all intentional. So much of the development work was human factors engineering, a ton of wear studies, a ton of thinking about how fast could patients turn it off if it was a false alarm. All these things that had to do nothing. Now, I don't want to minimize it, because our EE team that basically took this, miniaturized, and put it, it's a feat of nature to all that packaging. But nonetheless, it was a combination of all those things. And then on top of that, an algorithm that really works well seamlessly with the interface that we developed. So a lot of different technologies bundled into a package that for the patient. So I'll give a simple example too. So one of the other things we learned from patients is that those other products had reusable batteries. And patients had to charge them. Patients oftentimes forgot to charge the battery. So they'd be walking around with a defibrillator with no battery, which is pointless. And it's crazy. So we wanted to figure out, well, how can we make it to reduce the number of steps? So whenever our device, the way it works is, you get it put on, you wear it for a week. The other big thing was, those products are not waterproof. That's a big deal, because I would hope that most people take a shower once a day, maybe once every other day, in this, whatever. But it's something it's an activity of daily living. The problem is, if you force someone to take the device off, that's an opportunity for non-compliance. They won't put it back on. So one of the first things, well, we have to make it waterproof. The other reason was I always am amazed when we talk to physicians about this. We recently talked to a physician. We asked him, how many patients of yours have died in the shower because they weren't wearing their wearable? He said 4. Just one physician had 4. And even in a large study of the other product, one of the patients died, and it's listed because they weren't wearing it, because they have to take it off while they're in the shower. So even if they want to be compliant, they can't. So that 23-hour statistic is actually a little bit misleading. When someone's wearing our product, they're 100% compliance for 6-7 days at a time, because they won't take it off. It's on them the whole time through showering. Then when they change their patch every 6-7 days or whatever, that's when, but that's typically not during nighttime or in the shower or anything like that, and that's a small period of time. So really understanding that the big unmet need was, how do we make it waterproof? How do we make it an experience? How do we make something that people can live with? Those are what all drove. So it's really not it's a defibrillator in name, but it's really a human factors exercise in reality.
And just as a shout out of great recognition for that human factors exercise, the product recently won the prestigious Red Dot Design Award. So,
Yeah.
And you don't see that too much in the medical device space, and looking at what are also very consumer appealing products.
Yeah.
So I want to take us in a little bit of a different direction of looking towards the future. We're in the middle of a change in administration right now. As noted, President Trump was sworn in on Monday and has issued a flurry of executive orders. Some of his proposals for healthcare-related positions include RFK Jr. To serve as the Secretary of Health and Human Services, Dr. Mehmet Oz to lead CMS, Centers for Medicare and Medicaid, and Dr. Marty Makary, a Johns Hopkins surgeon, to serve as Commissioner of the FDA. I'm curious, looking forward to where we're at now, is there anything you're particularly looking at towards these next couple years?
So I would say that regardless of administration or regardless of executive order, I think if anything, what I've learned here is from my experiences at all of these different places, it behooves people in the industry to be stewards of their patients. That won't change, administration-wise or not. They still will need the same things. I would only say that perhaps now it's even more important to really think about what are the needs of various patients. And I would maybe term it maybe in a way that might be a little different than the last few years we've done. I think there's a lot more socioeconomically similar for most Americans in terms of how they get their health care. That is a reasonable place where there's a lot of commonality. I would probably say that even though people politically don't vote this way, someone in inner city Detroit probably has more in common from their daily lives and how they get health care in rural Appalachia than perhaps two other people in the same city but at different socioeconomic strata. So I would say focus on the unmet need and really focus on patients and what their lives are like in terms of what they have to go through to get health care. Because that's where there's a lot of opportunity. And I think pragmatically, like I said before, we went to these other states and we'll go back to those states to launch and kind of become, not just for our trial, because we really want to, like, we just think there's unmet need. But if you also show that even for people who don't believe in the value of thinking about socioeconomic or other diversity, if you save a whole bunch of patients' lives and you obviate costs for people like having arrest and going to the hospital and having to be in the ICU forever, et cetera, that's just good business. And over time, you take the baby steps required to start to highlight that, hey, diversity in all the different forms is probably a good thing to think about if we want to reduce healthcare costs. Because that's where a lot of money goes, because not necessarily people go to Stanford Hospital, but many other places, they can't. Like, and if you think about it, if you're poor, or if you're a single mother, or if you live in a food desert, your ability to get good health care timely is not that you don't want to. If anything, you really care about it. People are depending on you. But it's just the reality. And so really thinking about those patients and being stewards of how they go through life, it'll be more important now than ever, because there might be things which are glossed over with the stroke of a Sharpie that will be different than maybe other administrations. The other thing I'll say is obviously about AI. So as someone who's been involved in companies on the machine learning and AI front for quite some time, I think what's most important is that, first of all, everyone should get really knowledgeable about the differences. You know, I explained to you what we do in our binary classifier. That's a machine learning algorithm. We see so many technologies now which are like, well, we have AI. No, you have an algorithm. What is it? Is it a machine learning? Where is it along the chain? When does AI go? There's a lot of things being thrown around, so really getting knowledgeable about what's what, how do they different work. There's lots of different types of algorithms, lots of different approaches to machine learning. Thinking through that will be something I think that's very important so that you can apply the right tool. It's kind of like you think about when OpenAI came out, everyone was like so excited about these really massively large parameter models. But there's a lot of problems that can be solved with very small parameter models, because that's all you need. And so why would you build something massive if you don't need to? It's because if you don't really educate yourself on what's needed, it goes back to what I told you about Netflix model versus cell phone technology for the technology of the day. Today is different. If I started iRhythm today, smartphone penetration among all of our patient population, including the elderly, is different. So it's a different time. So I think my point is you need to be really thinking about where technology is going, but then look at where patients are today, because they're not always the same. And if you only shoot for where the puck is, sometimes that's good. You have to build that in so you can get there. But if you put that too early, you might oftentimes limit access. So in the case of AI, if it's a tool that will help you solve a problem in whatever need you're addressing, great. But then really try to understand what type of ML, what type of AI, what do you really need? Because again, the more lean you can make it to do 99% of the work, that's better for you in terms of compute and a lot of other things. So I don't know if it's the administration per se, but I think it's more, we have to be very detail-oriented to think through these things when larger swaths of decisions are making at a higher level that kind of, you know, make it nebulous about, you know, what's really going on. That's our job.
Absolutely. So just to ask one final question here, and then
Yeah.
I'd like all of you to start thinking about your questions, because we'll have about 10 minutes at the end for you to raise those as well. Clearly, biodesign has had a big impact on your career, as well as, you've had a huge impact on biodesign in everything from being, a fellow, faculty member, executive education, biodesign, both here as well as you were part of starting the Biodesign India program. I believe you served as director of the India and Singapore programs. And I'm curious, kind of, as you if you look back at that journey, is there anything that really stands out to you in sort of that impact in both directions?
Well, I think when we talk to fellows, it's when you enter the program, you come in thinking about solutions. The fellows are last one. But when you leave,
a lot of smiles in the front row here.
Yeah, when you leave, the minute you see something, you'll take a step back and say, what's the problem here? What's the need here? And it's very natural now, for me and many of the alum in the audience, that's their MO, that you stop and you take a step back. Is this really a problem? Why? You just stop talking. You stop thinking about widgets. And first, that's a good lesson for life in terms of thinking about not the solution, but what problem am I trying to solve? So I would say, I think the ethos of needs-based innovation, boiling it down to the idea of thinking about what's needs, I think you could think about it at 3 levels. So first of all, obviously we're not at your project in your professional career. What need do you want to solve? Wherever you're working. But I think that goes to a larger question about you personally, and I think when the implementation teaching that some of the fellows have already started, really think about your strengths and weaknesses. What are you good at? What are you not good at? What do you like doing? What do you not like doing? Because those are all constraints that you need to think about as you approach solving a problem for yourself. And what I'm getting at is not just professionally, but personally. What do you need as a person? What do you like to do as a person? Those are not, those may not always match. And so you have to really think about those things. I know a lot of times fellows, as they're starting their first company or going to their first job or whatever, ask, and I say, don't forget these other aspects about your life, your family, your kids, or whatever it might be. Those are all parts of and figure out what the need is there. Now, I can't say I'm always the best at solving it, work a lot, but it's important to think about how needs-driven innovation affects you personally, not just professionally. And then lastly, if you're fortunate enough to get to a position where you can think about it societally, I hope you'll leave with the fact that, at least what I'm trying to do, my little part of the world, is to leave it in a better place by thinking about what are the needs for our little community here in a larger sphere, and then more importantly as a country, what can we do better? How can we change the narrative? How can we change the next set of people who are going to impact? I have 2 daughters and a son, and I sometimes think about whether they go into science or not, but that if 20 years from now the industry looks the same and acts the same, I will have failed. So it's really important to change things so that we drive better outcomes for patients. And so biodesign, from the standpoint of really thinking about what do I really need, what does society need, what is my project or professionally, what do I need, is a good way to start in terms of thinking about where to go with your life.
Well, that is a beautiful note to end on. So sincere thanks for sharing your insights.
Thank you.
Round of applause. And I believe that there are microphones out in the audience. So we'll have time for a couple questions. So please raise your hand and we'll pass it over to you.
So it was great to see you.
Hey.
You've had exposure to some really great luminaries, and I would say, who are the maybe top 1, 2, or 3 that really stand out, and maybe the top 1, 2, or 3 things that you've learned from them, the real nuggets of wisdom.
Yeah, so I have to start with Paul Yock. So I would remember when I started iRhythm, one of the things that I learned one of the benefits of being here was being around a lot of luminaries, as you said, of physician entrepreneurs who've been successful. Bill New, who created the pulse oximeter, Paul with all of the technology in cardiovascular, Julio Palmaz. But Paul in particular, I remember when I went and showed him this, we were talking a little bit further along as iRhythm was, okay, I want to go do this now. I remember him saying like, this is interesting, but it's going to be a varsity challenge. I said, what do you mean by that? Like, it's not straightforward, but I can see that there's a there. So I think it was more honest advice, because oftentimes you don't get honest advice. You get like, yeah, you're a smart person. Yeah, it's great. That's great. People want honest advice. People want feedback that will help them and from an authentic perspective. So I think that is something I learned from him. I think one other person that, a guy named Myron Weisfeld, he was a very well-known cardiologist. He was the head of chief of Department of Medicine at Columbia when I was there, and he had done a lot of research before my time in AEDs, but he was very supportive. So I did something that was very unusual at the time because I was reasonably driven. So I actually did medicine in 2 years, cardiology in 2 years, and EP in 2 years. And usually that takes 8 years. And so he was very supportive of my coming to UCSF because of kind of what I was telling him I wanted to do, et cetera. So having also mentors who are more interested in what you're interested in doing versus interested in only if you're interested in them is a big deal. And I think whenever I get inbounds from students, regardless of whether it's from high school or college, I always respond. You always should respond because you never know who that person is.
My name is Nitin. We built brain mapping earphones. Back in our college, we were taught that healthcare is something that you can innovate with just a couple of electronics and build things. You just have to be great at what you build. But then later you realize the reality that at today's world, you need a lot of money to get through all these medical clearances, and there are these bigger corporations also out there. So in an ideal world, you just need to build a good product and then it goes out. But the elephant in the room is that it's a walled garden of innovation where young people who are part of Stanford Biodesign, are there challenges for us compared to what you had back in 2000s?
Yeah, even it was also changing back then. So I've given a talk before, and so I think probably back in the 80s and 90s in the medical technology industry, to your point, if you had a good widget, a good solution that solved a problem, start there and you could do something with it. What happened then in the 90s and 2000s, well, that wasn't sufficient because regulatory burdens and then more recently reimbursement pathways, I think were underestimated. And so a lot of the return on those early investments in medical technology companies started to take longer and longer and longer and take more and more time. So I like to think about and then back then also was the theory that you don't want to talk to corporations, like they might steal your ideas, though that really doesn't happen. So I like to think about when you're approaching an idea, ask yourself 5 questions. First, foremost, are you solving an unmet need that really you can validate that people will say that this is a problem? 2, do you actually have a solution? So those 2 are not unique. This is IP and all that. The 3 other questions, like, do you have a clear regulatory pathway? Do you understand how you will get this regulated? And that includes what the clinical burden will be. The 4th question is like, do you understand your pathway to payment? How are you going to get paid? It's an unfortunate situation because you're developing something very novel. You don't know, but investors will likely want to understand that. And then 5th, what do corporates think? Like unlike in the biopharma industry where there are many acquirers for all different assets because you can license a molecule, you could put it with a particular sales force, et cetera. In medtech, it's much more like for a defibrillator, there's probably 3 or 4 companies that would have a sales force or a infrastructure to do that. A orthopedic company won't buy a defibrillator company. So you have very limited buyers. So instead of the dogma of the past, you really should understand, do they care about this space? Are they doing something in this space? Do they have IP in this space? Because if they do, does that mean one of your potential acquirers is not there anymore? Because if you don't answer all those 5 questions, smart investors will ask you those 5 questions. Because I think oftentimes people say, well, I just want to raise a seed round. Now, tech is very different. Software and tech is very different in terms of time to get to market, time to release product with perhaps, it could have bugs in it. You can't do that, obviously, in medical products or digital health or things like that are regulated. So you need to understand that if you're asking a Series A investor for like $4 million, but there's 100 million more to come, they may not be that interested because they're going to get diluted to nothing. And so you really need to map out, and what we teach a lot of the fellows is like, what's your operating plan to the point of some liquidity event, whether it be, and that is for many products, even if they seemingly small, we all can attest to that. These take years and a lot of money. And so I wouldn't say that you shouldn't think about it, but think about doing it, or there's too much of a barrier. But I think it's important to be realistic and also understand where you are in your journey from a strength and weaknesses standpoint, so that are you the good fit to meet the risks of the day at that moment? There's a question back there.
Do we have time for one more? Okay.
Yeah, there's one back
One
there.
more. We could get a microphone. Oh, perfect.
Okay. Yeah, I had a question building off of what you said about regulatory challenges. Getting iRhythm and also Element off the ground, were there a lot of regulatory hurdles, like the 510K? And were you able to identify perhaps like a predicate device to accelerate that?
Yeah, I would say, so iRhythm, at a high level, 2 510Ks, one for the device, not so problematic because it's essentially sticking to you, and so the algorithm was more, but we were able to get through it because it was just a lot of testing. Those were both 510Ks. Element, as I look at some of the people from my company here, that's a different beast. As a PMA, this is an original PMA. So PMAs are not that many every year, and this is a life-saving device, so it's a class 3 medical device. I think the thing we've learned over time is that no matter how often you talk to FDA, they sometimes, not always, forget what they told you before. And so it's important to continually remind them every time you talk to them, like, remember that, and really lay it out for them again. And also, sometimes you get stuck in a situation where they're learning with you. So AI is a big deal. So our machine learning algorithm, even though it's not that, it is complicated, but it's not machine learning in real time. It's fixed once it's on the device. Really getting, as FDA has gotten more and more interested in understanding how to regulate AI and machine learning that exists as parts of medical devices. So we get a little bit caught in the crosshairs about being asked questions which are not relevant, and again, you just have to be patient and say, okay, we're in this journey together. So I can't, it's bespoke for every product, but you have to really read the tea leaves a little bit and just be repetitive.
How about one more round of applause?
Thank you, Kate. It's great to be here.
Great. Really enjoyed
Yeah, it's fun.
enjoyed the discussion. Thank
Yeah,
you.
it's good.
So thank you both. I particularly love the idea that you left us with, Uday, that we can all have an impact and we all have a responsibility to leave this tremendous field better than how we found it when we entered. So thank you for that. So we've got some thank you gifts for both of you.
Thank you.
Thank you.
There you go.
Let me say, it says about biodesign. I have many over 20 years. Thank you.
Yeah, so thank you both again. That was fantastic. As I mentioned earlier, there will be 3 other Innovator Workbench events this academic year. So we've got on February 26th, we'll hear the story of the tremendous impact Stanford Biodesign has had in catalyzing a health technology innovation ecosystem in India. On March 10th, it'll be my pleasure to interview Michael Ackerman, CEO of Osani Bio. Michael is not only a serial entrepreneur, but also a pioneer in applying need-driven biodesign innovation principles to the biotechnology field. And then on April 16th, we'll hear from Todd Brinton, our longtime Innovation Fellowship Director, who co-founded Shockwave Medical and is currently Chief Scientific Officer at Edwards Life Sciences. So continuing our alumni spotlights, to register for these sessions and to stay informed about other events, please follow us on social media or go to the news and events page on our website and make sure that you've signed up for our community email list. So we now have refreshments and networking, and hopefully Kate and Uday will stick around and answer more questions. Thank you all again for coming. This is tremendous turnout. Great to have you.
Thank you.